Zombie cells. Oh my God. My skin. Zombie cells. There are zombie cells in my skin and they're multiplying. Oh my God. What am I going to do? The beauty industry loves to scare the shit out of people. And what can be more scary than zombie cells? These are cells that are neither alive nor dead, and they're multiplying, infecting healthy cells and destroying the skin. Let's take a listen to the fear mongering. Right? Wrinkles, dull texture, unbelievable what zombie cells can do. And the fear mongering is working. It's working. Take a look at this segment with Penn Smith, master esthetician.
I think that if you just hear cellular senescence and you don't understand it, you might be like, yeah, whatever, it's just another thing. But it's actually the thing. To me, it's the thing.
She's scared. She is definitely scared. It's not a thing for her. It's the thing. So obviously, we had to take a look. And because I'm biased, I make a product that theoretically competes with products that treat zombie cells. I asked Agostino Demonico to join me on this investigation. Agostino is a very diligent scientist. He's a food scientist and nutritionist, skincare nut, and he's a wonderful person that I've gotten to know over the last 2 years. And so we've spent the last 6 weeks reading every paper on zombie cells, otherwise known as senescent skin cells. And we've got the story here for you, and it's broken into 3 parts. The first part, Agostino takes us through the basic science and terminology. And we need to know this because otherwise it's really, really easy to get fooled, even by the scientific papers. Sometimes they're trying to fool you, and you need to know the facts. So the second part is we go on a short, incisive journey through the scientific literature, and we make a clear conclusion on the fear factor that you should associate with zombie cells in your skin. Then in part 3, we discuss things that you can do to prevent a zombie apocalypse if it ever happens. And the good news is you're already doing these things. Hint, tomato sauce. Yep, tomato sauce. Now, with no further ado, let's join Agostino on this Aeducator investigation. So, Agostino, I think the first step is to explain the biology of senescence. How does it happen?
Exactly. So I will first start talking about the cell cycle. The cell, during its life, goes through several stages. We have the G1 phase, where the cell is growing. The cell has a lot of protein synthesis. It's really active. Then the next step is the S phase. The S phase is the phase of the cell cycle where there is DNA synthesis. And between the G1 and S phase, we have a checkpoint. The duty of the checkpoint is just to check if the cell has any DNA damage. Because if the cell in the G1 phase has too much DNA damage, then it's the duty of the checkpoint to stop the cell from going to the S phase. Okay, we are at the S phase. If nothing is wrong in the G1 phase, not too much DNA damage, then the cell duplicates the DNA, and then it goes to the G2 phase. So in the G2 phase, there are all the cellular rearrangements needed to have an optimal mitosis. And then finally, we have the mitosis itself. And between the G2 and M phase, there is another checkpoint. The duty of this other checkpoint is exactly the duty of the first one. It's to check if the cell has any DNA damage. And why these checkpoints that I mentioned are so important? Because we don't want a cell with DNA damage going through mitosis, because this is basically called cancer. So we can consider senescence as a protective mechanism.
Now, let's talk about how cells actually get into senescence.
Okay, the first and most important thing is damage. The cell must be damaged in order to enter the senescence stage. So, what happens when the cell gets damaged from, for example, too much free radicals, from too much UV rays? The cell try at first to fix the damage by secreting growth factors and other repairing oriented molecules. And if the damage is repaired in a reasonable amount of time, the cell goes back to life as normal. But if the cell is not able to repair the damage, then the body triggers the cell to say, well, now I'm in a state of senescence, so I'm dangerous to healthy cells. So what I'm going to do, I'm going to call the immune system, the immune cells, so these immune cells can kill myself, and so I avoid to trigger damage to other healthy cells. This is basically called acute senescence, okay? Acute senescence is where everything goes in the right way. And when the senescent cells are not cleared by the immune system, then we call this stage chronic senescence.
The industry actually has created a great name for them, zombie cells.
Exactly.
So now we have zombie cells.
One possible reason for the immune system to fail to clear senescent cells could be aging, because with aging, the immune system becomes weaker. Cells can become damaged from different sources. Okay, so we have different kind of senescence. One cause of senescence is aging. Telomeres protect the DNA, and with each cellular replication, they shorten. And so with aging, they become shorter and shorter. And when they are too much short, the cells trigger senescence. Then we have a second case. There is the genotoxic senescence. We have an external source that causes free radical damage to the cell. These external sources triggering damage to the cell, they also trigger senescence. We have also another cause, and it's oncogenic senescence. When the cell is exposed to oncogenic molecules, the cell triggers senescence. Okay. And then we have another case of senescence, and it's mitochondrial dysfunction. During aging, we have a natural decrease of the NAD plus production, and this decrease in NAD plus production triggers a senescent state that it's not associated with the production of inflammatory cytokines. Okay.
Great. So now we know there are different flavors of senescence depending on the damage that's caused by the cells. With aging, you have this slow wearing away of the telomeres. This makes the DNA susceptible to damage, and that triggers senescence. Or you have external damage or internal damage through tumor formation. And then you have another physiological state where the mitochondria in the cell just aren't able to keep the cell functioning in a normal way. When we discuss the evidence for whether you should be worried about senescence, we're really going to be talking about the first state, physiological senescence from aging.
Exactly.
Yeah. Now, how would this be dangerous to the skin?
Okay. So in theory, chronic senescence is a lot damaging to the skin. When we have a few senescent cells, they will start sending inflammatory cytokines and free radicals to the surrounding cells. The surrounding cells gets damaged. This damage triggers senescence, and then these other cells will trigger senescence to other healthy cells. The danger of senescence is that it's spread in the tissue. So we have cells that die that are not replaced with healthy cells. So we have cell loss in the tissue.
So this is really a great point, Agostino. So not only are the senescent cells creating an inflammatory environment, right? Where
Yeah,
you would expect to see the skin more inflamed, but you should also see reduction in the quantity of tissue. So the amount of skin, right?
exactly. We should see a proper shrinkage, a proper atrophy of that tissue.
We're preparing to dive into the scientific literature, but before we do the investigation, we need to understand some nerdy scientific terms.
Let's start with the H2AX protein. So this is a marker of DNA damage. So when DNA damage, this protein gets activated. And this protein activates because it recruits DNA repairing proteins.
Great.
Then we have P16. This I consider the most important marker to diagnose senescence because it's the protein that stops the cell from replicating. And then we have some growth factors like epidermal growth factor and fibroblast growth factors. These basically are growth factors that help recruit new cells to replace the damaged cells. And then we have some inflammatory signals like interleukin 6, interleukin 8, and granulocyte colony stimulating factor.
And so what we're talking about when we talk about SASP is a particular profile of inflammatory markers where IL-6, IL-8, and GCSF are particularly present.
This is a really good point. In fact, the SASP profile of the cell change depending on the senescent state of the cell. So in acute senescence, we have a different SASP profile than in chronic senescence. It's more about repairing.
So more growth factors and less inflammatory cytokines.
Correct. The problem with senescence is that it's really, really difficult to declare if a cell is senescence or not. We can't use just one of the markers. We need to use a combination of them.
We are now ready to go into the scientific literature and see, okay, how much of a problem is senescence for the natural aging of the skin. And just to sort of clarify what strong evidence looks like, I'm pulling up a paper that looked at senescent markers in sclerosis. So sclerosis is a very severe disease where the skin becomes hard. We see a clear elevation in P16 positive fibroblasts, right? Fibroblasts. And why are we focused on fibroblasts? We're focused on fibroblasts because fibroblasts reside deeply in the skin and in a layer of the skin that is not susceptible to easy treatment with chemical peels and lasers and creams in terms of skincare, largely inaccessible region. In systemic scleroderma, we see a clear elevation in both populations of fibroblasts, the populations in the papillary dermis, which is closer to the surface of the skin, and in the reticular dermis, deeper down in the skin, we see a clear elevation in P16 positive cells. The population more than doubles from around 20% to over 40%. We see an elevation in this secondary marker as well. This is what strong evidence looks like, right?
In a disease like systemic sclerosis, yes, we expect a strong senescence profile because there is a lot of free radicals production and inflammation going on. So cells definitely end up damaged.
So this is what we're looking for in physiological aging. We expect to see a doubling of senescent cells over decades, right? That's what we're looking for, right?
Exactly.
So now we turn to this other study, which looked at fibroblasts from breast skin. So we're not looking at sun-exposed skin here. We're looking at physiological aging. And what we see is really clear cut. We don't see any elevation from young adult to middle-aged adult to old adult. We look at the staining for P16 and P21 relative to actin. So this is really a clear evidence of no emergent senescence during physiological aging.
Exactly, exactly. This alone, it's a huge red flag. When we don't see the elevation of the most important marker for senescence, then most likely senescence is not going on.
Yeah, but senescence is one of these hot topics in science, a cool thing to study. So people are looking very, very hard to find evidence of senescence. So you have this group, Lupa et al., and they looked really, really hard. They looked at everything to try to find senescence. They couldn't find
Exactly.
it. They came up with a new concept, which is incipient senescence. So not actual senescence, but we think we see senescence starting to happen. That's again strong evidence that in physiological aging, you're not seeing senescence.
Exactly, Ivan. I couldn't agree more with your point of view. And I should also say that we have reviewed for this video many, many papers. And we found like errors in many of them, or like they test something, but they don't test other important things. It's really, really difficult to find a really good paper. And for me, this is an additional evidence that they're trying to make stuff up. What do you think?
Yeah, well, it's like Sherlock Holmes said, it's like the dog that didn't bark, right? Now
Exactly.
we do have one paper that did find accumulation of senescent cells in fibroblasts, and this is from Ogata et al. I'm showing some graphs from this paper. They're showing two things. They're looking at cells in the epidermis. They looked at the basal layer, and they're clearly showing an increase in the percentage of senescent cells in the basal layer over time. So when you start in your 30s, it's really like zero. And then by the time you hit your 80s, you have close to 30% of the cells senescent. So this is not exponential, it's more linear, but you're seeing an increase in senescent cells in the epidermis. Now, you and I have spoken about this, and we've said, like, well, why are you really that worried about senescent cells in the epidermis? Because here we have things that we can do. We can do a chemical peel, we can do treatment with cold plasma to rejuvenate the epidermis. We can physically remove senescent cells in the epidermis, right? We don't have to rely on the immune system. Now, in the dermis, they show an interesting situation. During the first 2 decades of life, you have really no senescent cells, right? And then starting in your 30s through your 40s, you have a clear increase in the percentage of senescent cells. It goes from 0 to 10%, right? No finessing, right? You see that.
Exactly.
I drew this line at the 10% marker. Through the next 4 decades of life until you hit your 80s, you're pretty much hovering at this 10% level, right? And I actually counted the dots, how many are occurring above 10%. In your 40s, 4 of the dots are occurring above. In your 50s, 3 of 5. In your 60s, 0 of 3. In your 70s, 5 of 13. And then you get to your 80s, and then you're really seeing a clear elevation in senescence. So I think that really what they show is quite interesting. They show an increase, then you have a plateau, and then you have another increase. And this type of curve where you have an increase and a plateau and then another increase, I've seen this in other aging studies, and I sort of believe this. What do you think?
Yeah, I do agree honestly with your opinion. This, I mean, this last study is the most convincing one that we have found that show that there could be some evidence for fibroblast senescence.
But here's the good news. So this group actually took these fibroblasts and they did co-culture studies. And they wanted to understand, how are these cells behaving, right? What are they secreting? And they found an elevation in growth factors, in an epidermal growth factor, they found a fibroblast growth factor. So they found that these cells are trying to repair. They don't report on whether these cells are secreting inflammatory cytokines. But I take this as evidence that they're not secreting inflammatory cytokines. Because if there was a clear elevation of IL-8 or IL-6, they would report it, and they didn't. So I'm sort of comfortable making the assumption that what you have here is a population that is more like the acute senescence phenotype that's being built up. So you have interesting new science, an in-between phenomenon where you have a buildup of acute senescent cells that hasn't shifted into a chronic cell behaving badly, zombie cell phenotype. What do you think?
Exactly. I also found really, really strange that they didn't report the levels of the inflammatory cytokines. Why not reporting? Probably because, as you said, they didn't found any increase. So most likely, I do agree that we are in front of an SASP that is mostly anti-inflammatory, mostly repairing. So an acute senescent state. We cannot say that it's a negative senescent state.
Agostino, let's give ourselves some credit. We looked really hard for evidence of increased senescence, zombie cells that could not be treated with normal skincare routines, and we didn't really find it. That does not mean that zombie cells aren't a problem for exposed skin, right? We can't say that
Exactly.
because none of these studies used exposed skin. So we could still have a problem on our face and on our hands and other exposed areas. That said, right?
Yeah, we know that the cell needs to get damaged to trigger senescence. So why to not use simple stuffs or change our lifestyle in order to prevent this damage from happening? Like, for example, antioxidants, okay, anti-inflammatory compounds. They are all going to help avoiding any damage to the cell, like avoiding too much sugar or carbohydrates, for example, it's another good thing.
So
Also,
in other words, a healthy diet, right? A,
healthy
a,
diet, exactly.
a healthy
Healthy
diet is,
lifestyle.
yeah, is the best way of avoiding senescence, right? And limiting the damage that the sun does. This doesn't mean necessarily mean limiting sun exposure because sun exposure is good for you,
Absolutely.
but limiting damage from sun exposure. And what are the things we can do to limit damage from sun exposure?
Well, actually using some protective stuffs, there are natural or synthetic. I do prefer the natural stuffs, of course. Also, we can use things internally, like there are some compounds like astaxanthin or any other carotenoid or polyphenols that have shown even taken orally to
Tomatoes,
prevent sunburns.
tomato
So
sauce. Yeah, tomato sauce, right?
yeah,
Lycopene.
lycopene.
Yeah,
Yeah, yeah,
yeah.
absolutely,
Lycopene,
absolutely.
astaxanthin. These are natural substances that increase the skin's ability to protect itself. So, just to summarize, right? Zombie cells for your skin, it's probably closer to an asteroid than anything else, right? So it's
Yeah.
like, okay, there's a theoretical chance that it's going to hit us, but it's not something we should worry about. So don't fall for the fear mongering of companies that are selling products to treat zombie cells. They're not necessary.
If you want really to improve your skin, we have like 1 million of things uh, to think about before senescence.
How many things do we put above senescence in terms of our priorities?
We have talked about lifestyle. Is your lifestyle in order? Is your diet in order? Are you taking the right supplements for your biology, for your biochemistry or not? I mean, there are many, many things that we should think before thinking about senescence.
Exactly.
So
In the process of taking care of our health, the health of our body, we're doing everything we need to do to avoid the small risk that senescent cells are going to damage our skin before we get really, really old. Right?
exactly, exactly. I couldn't agree more, honestly.
Okay. Well, that puts a wrap on it, right? We've done our investigation and we've come back and we can say, sleep easy. Those zombie cells are not going to get you. Thank you very much for watching. I'm excited to do more investigations with my partner, Agostino. I hope you enjoyed our chemistry and look forward to hearing from you. Thank you very much.
Thank you very much to everyone, and thank you, Ivan.